Okay, still don't have it all figured out, but I figured, well, I probably ought to go ahead and keep recording, just so you can see, because that's the whole point of this video, so you can see some of the decisions that go into making a product, your 3D printing, or or a product in general. One thing I do know is that we are going to need a cap piece to mate with a circuit board, to act as a retainer. Now that's going to be printed from the bottom up, so this will be a flat layer. Now that's probably have to be glued to a bottom piece, which is where our track for our ring here will actually slide in. Now the top of this cap will act as the top part of our, our top limit of our track, the horizontal guide that's going to be in there. And then it'll have a vertical piece, for each of these little, whatever you want to call these nodules, that protrude from the, from the ring here. So, and then the bottom of this piece would be the other limit of that. So this is basically going to end up being the fact that we're going to need a cap piece to contain our circuit board and mate with our guide piece. And I got to think about how the guide piece is going to be printed. And that's what I'm still trying to figure out, because I know below this piece is going to go our carrier for our switches. We're going to have something along those lines, for that little piece, little circuit board. But I just know this next section is going to be pretty much exclusively devoted to us, not just capping the LED board, but also having our guides. But right now, let me go ahead and I'm going to make some assumptions here, because I know we're going to need a hole in this cap piece that's going to be the circuit board retainer, so that our wires can come down, into our switch area. That's a given. So I guess I deleted all my, let me get rid of this. Okay, so it's going to have the same parameter, and let me just move this curve down here. Make sure it's still concentric, since I didn't use my elevator key. And this piece need not be that thick, but let's make it approximately 100 mil, a little under 1/8 of an inch. Yeah, let me make it minus 0.1 inch. Okay, so that's going to be our bottom piece, and that's going to end up going on this layer here. What the? So it's the electronics bay layer. Now here we're going to want a little piece to come in approximately approximately here. We want to make sure that we got tolerances so these two parts can slide together properly. I think this is our outer well, which is 1575, and our circuit board is 1542. So that's pretty good. So yeah, we want a circle about like that, because like I said, that happens to be our inner wall, of this, and we want this piece to be able to slide in here with no interference. So we got to again have tolerances for error in it. Okay, so having done that, I'll make this the diameter of our original circuit board, and let's see where that is. I'm using my arrow keys to nudge this, by the way. And I'll put that there, and we want to offset this again due to the thickness of the circuit board by, say, about, I go 25 mil. Well, I go 22 mil. Okay, so that'll be the start of that piece, and we'll just make it to where that overlaps a little bit, and I'll go ahead and meld these two pieces. Whoops. I'll go ahead and meld those two pieces together, so now they're a single piece, as you can see here. Next, we want, like I said, some kind of circle. So this is going to end up being kind of a ring structure, a ring-shaped part. And, this is arbitrary. We just need enough space to where the wires will clear it. So, but where solder joints aren't going to get in the way, too. So, because again, we've got our solder joints that are going to be here, and they're going to take up a certain amount of room. You can see where they're fashioned. So, we need to make sure that that part's not going to interfere too much. I kind of hate dealing with thin pieces like this, but darn it. Okay. So let's do a subtraction here. Let's see what we ended up with. Okay, so basically we got our lower ring here, comes in here, and there's an inner piece. Let me see if I can up the isocurve density here so we can see what's going on a little bit. Don't think that helped, but I think this is where the ledge is right here. You see this line here and this line here, that line there. I think, I was trying to get it to highlight that, but it just gets too confusing. I don't know where it is. I don't know which one of these lines is which comes the inner edge of this, is what I'm looking for, on the side view here. It'd be nice if this had a better mechanism for peering into parts like that. Let me see if we can. Yeah, that didn't really help. But at any rate, I suspect this line right here is an indicator of where it is. So that's what kind of room it has, what kind of a ledge that circuit board will have to rest on. And again, we got plenty of tolerance for it, without it being just too freaking loose. And really, since we got tolerance up here too, we kind of got a little carried away with the tolerances because, and again, that's one of the things that sucks about trying to build from the top down. I'm not used to thinking that way, because we probably got a little looser tolerances than we'd want, because depending on this distance, but again, this part here will probably be a little higher than what I'm expecting, so, by 10 mil or more, so, probably won't be as bad as I thought, but as I think, but the point is it'll still work. It'll just be a little looser than I'd like. This right here I have no tolerance, because the fact of the matter is I got my tolerance built into this, so that's why these two parts just butted right up next to each other, because it's not important, even though this part here will probably be thicker than what I'm expecting it to be by 10 mil or more. The fact of the matter is that still it's going to mate to this face, and that's what matters more than anything. And that it doesn't, the circuit board's not, this gap is not so big that the circuit board will not fit into it, and this will not mesh well, because this is part where the area we're going to be applying glue to. So we want to make sure that at least one surface makes good solid contact, and then other than that, that it'll actually mate together. So this area here will not interfere with this area here, and they will mate together, even if it is a little loose. Again, it's a prototype, you know, proof of concept or other, so it doesn't matter too much. Anyway, that's our circuit board retainer. Now from there on down, we're going to be doing our channel guide. And the circuit board retainer, the top of this, will actually act like the top of our horizontal guide, like you'll see. But let me go ahead and light up, you know, our ring, because now I need to figure out how short I really need this thing. That's odd. Oh, I accidentally locked the layer. Okay. Now I don't remember. Did we? I don't remember if this went up this far, or did it go up this far? No, I think it went up this far. Okay. Because I know it's 400 and in the high 400s, so that's probably where it was supposed to be. Let's see. Yeah, it looks about right. Give our cone position and everything. Okay, so that's going to be the maximum height, and we know that this is going to be our lower constraint. And again, I might end up having to actually make this longer. We'll see here in a minute. Which means I might have to redraw the damn thing, because I can't just grab a piece of this in Rhino and Rhino 3 and extend it. In Rhino 5 you can, but I can't do that in Rhino 3 without it being a whole big frickin' mess. But I might be able to just meld an extension to it if need be. We'll see. You see this ring here, you know, we want the bottom of this, you know, being the top channel, because this is where it's going to have to rotate, you know, horizontally, because it'll be raised just like I did. You know, it'll raise up and then it'll rotate in one direction, you know, which causes the holes to go out of alignment with the LEDs, which is what you want when you put it in diffuser mode. Because, you know, you don't want your light shining through these holes. You know, that's what we're trying to avoid by having this umbrella concept, you know, umbrella diffuser here. Trying to avoid light shining through those holes as much as possible. But in any event, you know, this piece we just drew will be the cap, but I'm kind of like, okay, so if I did that, that means this tube would be this long, and I don't know if I want it being too wibbly wobbly, or if that would be a problem or not. You know, because I don't want this tube, you know, to rock around, you know, back and forth any more than necessary. Although it may not be a problem. That would put our tube though at about 1 inch long. And it's, you know, when it's in a raised position, and it would, you know, only retract by, you know, but a little under 1/2 inch. So that would be its travel is about 1/2 inch, which we can go for that, but I'm still debating about whether that's enough of a raise on it or not. Because I'd like to have 2 levels in it if possible, but that's going to be a little tricky to 3D print, and I'm still kind of wondering if I can get away with that or not. But if I had 2 levels, for example, this may be the first level, and this would be the top level, so it would be, you know, an extra 3/4 of an inch, or I mean a 1/3 of an inch or so higher than we have it. because I'm still not sure. This is still experimental in terms of actual practice, what this thing actually looks like in reality, and that's what that's why when you're dealing with LEDs and things like that, you gotta try to build in your proof of concepts or your prototypes, some adjustment factor, so you can actually play with it if at all possible. It's nice to build something like that into it. Let's see. So I'm almost thinking, if this thing right here actually had almost like a blade on it coming off of it, that I could make a piece shaped like, just follow my cursor here, shape something like this. So, with a bunch of little notches in it, so you could actually raise it up and twist it, 1/3 turn, and then have this blade go into a notch, and then you could actually have several different heights, depending upon your own preference. But in practice, you probably wouldn't want to do that. You'd probably just, most people wouldn't want to, they just really want the thing to work. They, probably wouldn't want to tweak it, ad nauseum. So, but still, for experimental purposes, it's kind of tempting to think about doing something like that. But again, I've yet to make up my mind on it. I'll fill up my whole hard drive space trying to make up my mind on this. Because a lot of these types of things, it's really just a matter of sitting there thinking about it and trying to consider the ramifications of doing it various ways, because again, it's not easy to change your mind in a CAD program like this. So, there's a lot of work you got to put in ahead of time, as you're making it. Let's see. There's something unsettling though about sitting here doing things like this when you're being recorded. It's kind of hard for me to sit here and kind of be as free flowing thought wise as I normally am. That's why sometimes I like to turn this thing off so I can think freely. On the other hand, I kind of desire to capture some of the decision making that goes into doing things like 3D print design and so forth. Because again, these concepts, no matter what CAD program you're using, still apply. It's just a question of what whatever package you're using, you're still going to want to have similar output, and that's what I'm trying to capture here. Is not so much the use of a given CAD system. I mean, this is a custom interface of mine, for crying out loud. You're learning to use like Rhino 3, and again, my toolbars would work with Rhino 5. They do work in Rhino 5, although it's a little more crowded of an interface. But again, it's not so much about one given CAD system or one given 3D printer, but the process of designing parts to be 3D printed in the simplest possible way, without complicating things too much. But it shows you some of the decision making that goes into it and some of the compromises you got to make. Not just for this too, but also for if you were going to go into production on such a product. Let me look at something real quick. Yeah. Okay, so that's the inner wall. So the batteries are barely clearing it from the looks of it. But again, I may make the base of this wider to accommodate the batteries, because the diffuser part should be in the top. And I know we're going to have a switch in here somewhere, so the battery compartment will probably be completely removed from our whole mechanism up here, you know, along with the switch circuit boards right underneath it. You know, but as soon as we clear this, we can actually start flaring the base of the flashlight out, or the candle out a little bit. Flashlight / candle. So we won't have any battery clearance issues, I don't think. But so one of the questions I had was this. You know, if this was the top position, you know, you can see that this part we just drew, you know, this would be pretty much resting up against the bottom of it, you know, give or take. You know, is that going to wiggle about? It shouldn't with 3 guides in it, or 3, you know, nodules blocked in guides. It shouldn't be too wibbly wobbly, even with a short tube like that. So if I did just want to make the tube this long, I could, but I still say I'm really kind of inclined to make it a little longer and make 2 positions for it. But that may necessitate depends on which direction I'm going to print it, but I think I'm going to have to print it from this being the first layer down here to this being the top layer up here. And that ring we just made, you know, actually could be, well, we can't capture it. Have to be glued onto it. There's not going to be much to base it off of, though, because of the tracks. Like I said, I wish I could have a key in it of some kind to lock the alignment in properly, because it's certainly going to have to be keyed to that diffuser, depending on how that's installed. See, this diffuser is going to be a separate piece of acrylic that's going to be glued to this PVC tube somehow. Still not sure exactly what glue will do the trick. Hopefully, I guess super glue or industrial adhesive might do the trick. I wish this was acrylic. I could use my acrylic cement with it. It's great stuff, by the way. I'm trying to think about how this might be assembled. Because again, that's why I want to put the ring on first. Then, I guess if the ring is in seated position, though, you just put the, you know, this would be pre-assembled, because this tube can be rotated so the holes align. So if this ring is in its retracted position, just use the LEDs as a guide, and you put the glue, and then, you know, lower this tube assembly on it and get it aligned with these LEDs, and then it'll be in the right position, I suppose. Okay. Yeah, I guess I could do that. So if this was the bottom down here, this next piece, you know, I actually could have 2 guides on it. And in fact, I wouldn't even have to have this as a cap piece, except that I need to have a cap piece on it, because we've got to have some way of getting this ring, you know, into the channel to begin with, once we carve channels into this next piece. so it'll still have to have a cap piece, but it does not have to be located there. So what I might do is actually bring it down a little bit and make that the topmost position. That way, when I glue this piece to what the new piece we're about to draw, it'll be the same diameter, and it'll be more easy for me to just visually align it. That's going to be a little bit important here, you know, given the fact that we don't want it running into this tube in any way. But then again, it's got this clearance here, so that shouldn't be a problem. On the other hand, I may want to make sure I use the proper keys when I move this. It'd probably be good to have this piece below the joint between this lower piece and the upper piece here, because again, when you're gluing things together, sometimes these parts are slightly not aligned, and especially when you're dealing with like super glue, it's kind of hard to get them precisely aligned. Even if I use this industrial adhesive, which works pretty well. Let me see if I can find it. You know, JB Weld works with it too, but it's a little thick and it makes it kind of bleeds through the plastic. And I bought this off Amazon, this E6000, which is a slow setting industrial adhesive is what it is. It's industrial strength adhesive. And it works quite well with this stuff, but you know, you have to, you know, apply clamps to it and so forth. So normally I use super glue, but it's not as strong as this stuff. This stuff's pretty good, but it does take it a day to set, and I think several hours before it's even you can even touch it. It's like very slow drying model glue, but I don't know if I'll use that or super glue. Probably just super glue. But at any rate, just even if you get the, you know, sometimes it's almost impossible, because sometimes two parts may be the same diameter, but for some reason or another, you know, when they're 3D printed, they don't always match. So, not exactly. So there's sometimes some error in it, I've noticed. Again, if I had a dialed-in printer, you know, I probably would be dealing with some of those problems. But again, that's what's good about me doing this way and showing you this way, because even if you bought some fairly crappy printer, you know, that may not have the greatest precision and tolerance in the world, well, you know, this is some of the procedures you'd want to use. So that's why it's kind of universally applicable to any combination of, again, software and hardware you might have. But at any rate, yeah, I think that's probably what I'm going to do. This would be the topmost position here in our guide. So that'll be the top of the stack, and then the next topmost position, you know, which, like I said, which is not the position we have it in here, but our next position might be, say, here, which gives us the height we have right now. But that would give me the ability to raise it by that much. So if I light up the cones, so if I light back up the cones and grab these pieces here, we can test to see where it would go, you know, right there. So, you know, you can see the cones here would actually bleed. I mean, this is almost fully, you know, it's kissing the edge here. I wouldn't want it any higher than this under any circumstances. So I know this would be a maximum position that I'd want it being in. See there, you know, that would be in a maximum position. You know, I wouldn't want it any closer to the edge than that. That's right kissing the edge. In fact, that would, you know, this will give you some side shadow if you're here. In fact, I would say that would be too tall. Let me get a measurement off this real quick. Again, a lot of this stuff too is based on instinct, you know. A lot of it's not calculations or math. A lot of it's based on instinct and skill. Yeah, that's about 0.9 inch. Again, I think we could actually come down a little bit. So let me undo that. Now let me redo it. Okay. Grab this stuff all again. And let's shift it down by about that much and see how that works. Okay, that's a little better. I'm a little happier with that because I still don't want it bleeding to the edge, even though again there's going to be some overlap there. That would be our ideal position right there. So I think now I can go ahead, now that I've looked at the extremes, I think I can go ahead and push these together here like that. So that's going to dictate, that's going to be the length of our final tube. So when I cut the tube, and I can cut that tube to any length I want, basically it'll be approximately 1.628 inches minus a little bit, but I'm not going to be able to do it with that precision. So there's going to be some error in this anyway. So, but you know, there's certainly going to be a little bit of space here due to this part being a little thicker than I thought, and you know, you'll have some glue in there and some uneven cutting, you know, some uneven cuts in it, in the tube itself. So, so that gives you an idea. I'll probably cut it on my table saw with my plastics, $200 plastics blade in it. Just spin the thing around, you know, to try to keep it uniform is probably how I'll do it. Piece I have of is cutting a bandsaw. But at any rate, this is the length we're going to settle on for the tube. Okay, this is the well, hell, what was I doing? I wasn't paying attention to what I was doing, was I? Like I said, this is the topmost position. So, and like I said, we're gonna we want that to not quite overlap this joint, like I said. So I need to shrink the tube further than I did. So that's going to be the length of the tube right there, because that's going to be a fully raised position. Okay, and then its next position will be here, just like we had it earlier. So basically, you know, between these two positions, you know, that's position, that's the highest position, and that's the next highest position, and then we got our rested position. So that's high, low, and this will be our minimum position right here. Approximately like that. I'll leave a little bit of tolerance for error there because it doesn't have to go clear down it, so clear down, so that's the most raised position, that's the second preferred position, and that's the seated position. So that's the range we're going to go over on that. So it's something like that, so about 0.8 inches or so. That's going to be our travel on the tube diffuser combination, tube diffuser ring combination. So that gives us an idea of the extents of the next part we need to make. it's certainly got to be, it's going to range from the bottom of this down to below this ring. So, and then below that, it'll ostensibly act as a cap for our switch circuit board in some fashion. But we'll see, because remember, this is going to be the bottom of it, and it's going to print up. So, and you'll kind of see what I'm talking about a little later when it comes to these tracks, because remember what I was talking about earlier, see when we're printing up, if this is the bottom layer down here, and as we raise, I can easily make a flat ledge, like an indent, and then go vertical, but I cannot come out horizontal again because it's going to be printing in free air, but I can go at an angle like 45 degrees or so, and then pick up where we left off. That I can do, so that could be a guide, for one of these little nodules to go in for a horizontal adjustment, which you're going to see us make, because we're going to end up with two horizontal adjustments that are, about 120 degrees, a little less than 120 degrees each. So you're going to basically, when this candle, when you're wanting to put it in a seated position, raise it and put it in a seated position on this diffuser, you'll give it a third turn, a little less than a third, of a circle, a circular turn. So, you're going to rotate it about a third of a full turn, just a little under that. So we're going to end up with these horizontal guides that these little nodules are going to have to go into, and we'll have one central vertical guide on each side. For each of these little nodules here, there'll be a vertical channel, that allows us to raise it up, and then when we hit the horizontal channel we're interested in, then you give it a twist, a third round twist. But our twist, is going to have to be like this because of the ledges. Now the top of our guide will actually come clear to the top, so I'll have an escapement, so that I can actually put this thing in the first place, because like I said, I got to get the ring, when I'm doing the assembly, I got to get the ring on here somehow. So this vertical channel will go clear to the base of this, although our actual horizontal channel will come across here, going like that direction, for example. But that's how I'll install this ring, get that on there, and then we'll glue this thing on there. Then we'll, like I said, glue this assembly here onto it. And see, you got to take all these things into consideration when you're doing designs. You can't just think about the design itself and the functionality, but how the hell are you going to actually build the thing? I mean, when you got all your parts printed up and together, well, okay, it's nice that they fit together, but well, if there's no way of assembling it, no practical way of assembly, well, back to the drawing board with you. That's what you're going to end up doing, and that's why you got to think about all these different things. There's just a lot of decisions you got to make in designs, and engineering is nothing but a bunch of compromises. Engineering really is the art of managing compromise, is what it is. And again, so much of it boils down to decisions like this, not really so much crunching the numbers and so forth. I mean, a lot of this kind of stuff, really doesn't involve a lot of math. It's just a matter of whether things fit together or not. So, and just keeping some tolerances in mind while you do this, and think ahead. But you got just a multitude of decisions you got to make when you're doing design projects like this, and it's time consuming. So, and you can't just rush through it because it takes a lot of time to redo it, especially if you got a CAD program like this. It's not so easy. And even if it were, I mean, it takes a long time to print these parts, so you wouldn't want to go do like 50 different versions of the same part because you were in a hurry. Because haste does make waste when it comes to this kind of stuff. It really does. So, Oh boy. Okay, let's see. I'll go to the restroom real quick. Okay. Anyway, so we've established, you know, that we're probably going to glue this piece to this bottom piece, and the piece we're working on right now is going to be, you know, a slide, and that's it. It has no other function other than to take up this much room. So, which does certainly add height to our candle, and you know, that sucks. But I guess there are such, you know, there's such things as long, tall candles, right? So, let me see if I can. Yeah, that curve right there. Let me go ahead and move that down to here, and I guess we'll, without further ado, go ahead and get started. Now, the question is how is this piece gonna do? We know we need a hole in it because of wires, and of course, if we're going to production a part like this, we wouldn't want it to be solid plastic, you know, with a small hole in it. So, you know, I still like to try to think about things from a practical standpoint as much as possible, even though we can be freestyling on this kind of stuff since it's 3D printed. Like I said, it's more a matter of function rather than in form rather than actual DFM, you know, design for manufacturability at this point. But anyway, so we can have our raw base tube come down here. But at what distance? I mean, we know it needs to be below this. So I'm just gonna, you know, because this is 1100, you know, I'm gonna take it to just add 100 mil to it arbitrarily for now. Okay, now this, what I called the electronics bay, is not what we want to work on anymore. We want to work on the, I wouldn't call it the upper housing, so I guess I need to add a new layer. I'm going to call this the electronics retainer. And I call it LED. LED board retainer. Okay, this layer here, I tend to favor dark colors, they're easier to see for the layers. This will be just below that, and that's going to be our diffuser guide, guide channel, let's just call it that. Our guide channel. This will be our current layer now. Piece I just created, we will put on this layer. Let's see if the color looks good, I guess. And so like I said, this piece will ultimately carve our channels out of, which I could do that to begin with. You know, this program though gets really finicky about doing too many complex Boolean operations on a part, though. Sometimes I have to go to other programs and try to resolve it, and even then, sometimes I can't do it. Well, again, it pays to have higher dollar software. If you're doing a lot of this kind of stuff, especially if you're doing it for a living. I know some people that own SolidWorks, and so, you know, some programs like that, you know, I could go, you know, borrow their laptops or whatever. And if I go DFM some of these things, I might do that. But, okay. So we just created our channel guide baseline part, our primitive. Yeah, here we can see it, so we can see what's going on. You know, that's the part we just created. Let me go ahead and save. That's one of the things I love about this program is this incremental save. See, if I go to open up a file, you see how it's got 01, 02, 03. That allows you to actually retain a history, and I do that a lot. So when I save, I'll often use the incremental save instead, so it actually, if I need to go back to an early point in history and grab some part in a more primitive state, especially if I need to redo the whole part, sometimes you don't have to do so much work that way. The other thing nice about Rhino is you can have up to 99 undo levels too. I think I got mine set to like 40 right now, so that helps as well if you need to redo something. Let's see. If you're wondering, that's what a ray trace render of our current design would look like, with no textures or anything. It's one of the nice things about Rhino is you can do some really good renders with it if you really want to get into the Flamingo, because I got the Flamingo module for Rhino 3. They changed it a lot for Rhino 5. It's one of the things I don't like about Rhino 5. It's they made improvements to Flamingo, but on the other hand, it's a little funkier and it overrides your. It just works differently too. And there's several things about Rhino 5 I'm not sure I like, but there are a lot of things I do like about it. It's a pretty cool program. Overall, I mean, it's still more good than bad, but still there's some things I'm just kind of waiting around to see if they improve it before I think about throwing any money at it. But at any rate, let's see. Okay, like I said, we got to have our switch well, and it's going to print from the bottom up. Have our switches, I mean, in there. I'm just trying to think again, because I'm trying to think upside down compared to how I normally design these things. So I'm still trying to get the hang of that. Because I'm thinking, normally I've been mounting these these switches like upside down, but I might actually, since we're not putting any LEDs on them in particular, mount them right side up instead. And I'm still going to keep this, because it looks like, we'll have to see if I need to adjust these positions or not. Because I know we're dealing with slightly different diameters. I got too much junk in the way to see right now. But I'm still wondering just how complex this part's going to be, and whether I should maybe try to build a switch well into the top instead of the bottom like I normally do. But I'm not sure yet. I'm pretty sure we're going to have to adjust those switch positions though from the looks of it. Let's see. Okay. What I should probably do at this stage is go ahead and turn the electronics off, the battery off, the cones off, the PCB off, and don't need the diffuser or the lid. Or the top, or the retainer. Because what I'd like to do is go ahead and look at working on these tracks that I've been talking about. For these tracks, I thought I had a curve in there for that. I think I did, but I don't know what happened to it. Was this it? This was it or not. Let's see how big that is. That's about 30 mil. I think this was meant to be the inner curve part of the track, if I recall correctly. So we have 30 mil here and 30 mil there. For you, this was just a little while ago. For me, this is like 5 hours ago. So, because I'm, hell, it's probably 6 or 7 hours ago. So, for me, I'm struggling with memory. For you, you may not be, depending on if you're watching the whole thing in one setting or not. I doubt it. But, this would be the inner part of the track, so that needs to be part of it. The width, we're going to have a tolerance around that. This is the outer part of the housing, so we know that we're going to need to cut out a piece roughly like this along this arc, and then up to this to establish our vertical tracks. And like I said, that's going to go straight up through the top to allow me to assemble the object in question. But then later we're going to need the same circle for a horizontal track. But let me go ahead and just leave that alone, and we're on the right layer. Okay, so let me go ahead and just make a new circle. So you can see the new circle was hit there because I'm using project right here, and that projects it to the nearest plane, nearest working plane. There are times when you want to turn that off, but this isn't one of them. Because you can get some funny things happening, you know, if you're not careful. That's why you usually work with project on. Okay, so now that we got that, let me go ahead and trim a little thing out, make sure my on curve is lit up. Okay, so that's got us that there. Now here, like I said, we want to let's do an offset from the corner of this, and we want this to be, you know, again 30 mil or so. In fact, it doesn't hurt for it to be a little excess, have a little excess tolerance. So I'm going to make it, you know, 42 mil on each side. So I'm going to come clear up to here and come over here. Oh, I shouldn't have done that. Doggone it. Right there. Okay. And there's a midpoint. Now let me go ahead and delete this sucker, and I'll mirror this and join it. And then let's go and notice that, you know, since I'm using project, it's drawing this on the same plane. This is very important because we've got to join these curves. So let me go ahead and make sure our chamfer is set to 0, 0. Select that. And let's do it again. And that's giving us our piece. Okay, so now I need to take that down here, and we'll extend it to the very bottom of this. And it's okay to do this because, again, it doesn't matter if there's a little bit of loose tolerance in this or not, because, again, so much of our tolerance is made up in the actual length of that tube. So that's what really dictates how accurate this is, and that's only going to be as accurate as my cut, but at least I can make several cuts, you know, several different length pieces until I find one I'm happy with and test them out before I glue everything together. Okay, that's giving us this, so let's go ahead and do an array on it. Circular array. And then let's go ahead and grab this sucker here and subtract this stuff here out of it. Okay, so that's giving us our guide channels, as you can see. So you can see how they're seated in that, top and bottom, and they bottom out there as I design it. Now here pretty soon we want to put our horizontal channels in there, and I'm going to have to light everything back up to find out where those levels are, but we're going to have to put our horizontal channels in there so we can, you know, have this thing lock into place, you know, with a third circular twist. Okay. Well, like I said, it'll be interesting to see, you know, if Rhino will put up with this, plus us drilling a big hole in the middle of it and everything else without crapping out on us. Because Rhino 3 wasn't too great. I mean, it's okay at Boolean operations, but it's still very finicky. Rhino 5 is a lot better at it. Let me go ahead and just light everything up. back off later. Okay, so we've established our bottom position. Now I need to establish, you know, our next position up, which we know what our next position is. It's based on that line, which I had the presence of mind to make. And we know the other one is just right below this somewhere. So anyway, this position is where we really need one of our horizontals. Now this is where it's going to get tricky, and this I'm going to have to think about how we're going to have to do it. So I'm going to have to come up with some kind of a ring that goes over, but not to the next channel. I mean, you know, this next channel, you know, so that's why it's not going to be a full 120 degree twist, because it's got to fall short of this channel, because I don't want it to spin completely around, you know. I mean, I want it to actually have a set position, and the customer would want that, you know. Somebody that buys that wants it to go into a fixed position, a known position, you know. And even if it's just loosely sitting there, that's fine, you know, as long as it's in a known position. They know it's proper. It's just one of those little psychological things that you got to think about when you're doing product design. It's you know, something somebody's going to want. They're going to want this thing to stop when they're actually twisting it horizontally. So again, it's going to be a little tricky. So I got to figure out just how I'm going to do this. I'm going to have to take an arc, clearly, that's based on that same circle we just got done playing with. Wherever the heck that went. And you know, you start getting so many lines on here, you lose yourself. But we know it's going to be somewhere like there. It's going to be where it is. So, but that's in the wrong position, so let me move it down here. Again, using my nudge keys, my arrow keys to nudge. Now, let me grab this, and we'll start from here. On the bottom of it, I'll take right to the bottom. Boy, this is going to be complicated. I really think Rhino's going to have a problem with this. You know, because the profile of this I got to make, you know, not in a rectangle, but in a rectangle with an elevated, almost a conical end. So, and that's going to be subtracted from this other body, and I got to do that twice and all around the thing. So it'll be interesting to see if this thing has a conniption fit or not. Jeez. So I guess I got to figure out how this is going to come out. Let me see. Okay, I'll just have to make a cone, so I'll have to do it. Yeah, let me go ahead and take this actually and put it down here on the bottom. And we'll just have to use our, well, hold on a minute. Okay, so that's our inner part. Now, like I said, we want this to be like a ring, so let me pull it out to here and grab that too. Oh hell, that's on the wrong. Okay, sheesh. Move this thing so it aligns with that other one. Okay, so that's got both of our rings selected, I believe. Yeah. I mean, both of our circles selected. Okay, I'm just going to oversize this thing, and I'm going to use a cone to determine what the upper limit is right now. So, see, I made this ring here, but it is just a ring. So, now I need to make a cone, which has like 45 degrees on it. which we can use this curve for that, and extrude it at an angle of minus 45 degrees. Okay, so that's got us a cone there, and see this little track here we can see just edge on, and that's what we're going to want to use. That's why I also, you know, try to pay attention to how I'm actually designing these things. Man, it sucks that I can't see the inner wall of that better. Okay, this is our little nodule here. So here's our cone. Oh hell! You gotta be kidding me. Ugh. Okay, I gotta do it over again. Okay. Okay, so here's our cone. And like I said, you know, we gotta have that 45-degree angle. We don't want this causing friction here, so we want to make sure, and again, you gotta use your imagination a little bit on this, without doing a cross section. Again, some programs you can actually do a cross section. I don't think you can on this. Okay, so that's 15 mil. You know, because it doesn't matter again if this horizontal track's loose or not. You know, better loose than too tight. You know, because the surface finish on these things and so forth is going to be a little bit in question. So, you know, yeah, I definitely keep it to there. So let me take this sucker here and make sure, what the hell? Make sure I'm in elevator mode. So that's what we're going to want to remove from our outer ring here. You know, is that section there. So let me go and do that. Okay, now you got to remember what I've created here, because this is going to end up being, you know, even though it's way oversized, it's still our tool that we're going to cut material away from this with. However, at this point in time, I need to go and do a section on the thing, and given the fact that these things align, I can just cut it here, and let me go ahead and hide the damn electronics. We don't need that stuff right now. And we will in a little bit when I figure out the next position, because I want to figure both these positions out before we do any Boolean operations on the thing. Okay. So like I said, looks like here is our other channel. Remember, we got to fall short of that. You know, because here's where we ended up, you know, in this piece. So we got to fall short of that. That's interesting. I guess that's just an optical illusion. I don't know though. That should be radial. You know, this, I would expect this to be flat. You know, along the same. You know, I'd expect this line to be parallel with that line, and it's not for some reason. But then again, it isn't up here either, so look at how I did it. So that won't be a problem on 3D printing. You know, because what I should have done is I actually did a radial line out like this, but it doesn't matter as long as it captures it and we got it loose, so I'm not going to worry too much about it, although that may create some complications in Rhino trying to you know, trying to make these things without them being orthogonal. Okay. But I like that, actually. It's less friction. You know, if we can get away with it, it's a little less friction. Let me go ahead and I'm going to save a copy of this tool in its raw form before we do anything with it, in case I need to go back and redo it later for some reason. Like, for example, the 3D print or the Boolean operations failed. Okay, so I want to chop this disc in half. Come out and draw a big box here. There's many different ways of doing this in Rhino. This is just, to me, the easiest, less complicated. Okay. Let me undo that. Okay. Now, oops, I didn't realize that. I forgot to scoop that up. That could cause problems if I didn't do that. Okay. Now let me go ahead and rotate this thing. Okay, now let's zoom in here and find out where our deal was. And like I said, it's right there. And remember, we want to allow, you know, we don't want this thing to completely spin around, so we want to certainly add a little bit of clearance, you know, a little bit of a block there. So that's as far as we want the ring going from that direction. So basically that's our tool right there for cutting tracks with. You know, chew into that new base that we've created. Okay, so having done that, I need to triplicate this. So we got our 3 tools. Now that we've done that, let me go ahead and turn the cones on and the electronics back on, because now I got to go adjust our ring position so we can find out our next horizontal channel, and that was going right close to the bottom of that, sort of arbitrarily, got right like that. Whoa. Okay, so let me take a look at this real quick, see if we're going to have a problem. Okay, so that tool right there will cut in like this, and this is the bottom of our next one. I wonder if I can go higher than that. So this is a case where it might have been a good idea to, you know, actually make this thing longer due to this. I mean, these are one of the design constraints I'm talking about that it's kind of hard to anticipate, you know, because you're dealing with so many different variables, you know, when you're doing designs like this. In fact, we would have been better off having this tube be slightly longer, so this would be slightly lower, because what we're going to end up with is a very slim channel here, you know, because you can see this is the edge of the part we're cutting into, and you can see where our the tools we just made, you know, is going to slice into it like this. Okay, but then here is where our ring is now, so you're just going to have a very, very skinny you know, very skinny little piece going from right here to right there. That's going to be the limit of it. But again, most of our tolerance is in the overhead, so damn it. Sometimes that center thing gets annoying. Let me turn that damn thing off. Where is it? Okay. That's going to be only about 50 mil. That's not too bad, though. I think we can live with it. So, because I could risk raising this piece here up further, but, you know, again, I wanted to keep that shy of our joint just in case there's a mismatch between these two parts. So, that's a constraint. But, you know, I think this will work. I think it'll be okay. So, what I need to do then, you know, is basically take these three tools we made and duplicate them. Probably gonna have to do these sequentially too, because this might really confuse the thing if I try to do these all at the same time. Let me copy that to the bottom of this, so that'll be our next horizontal track layer. Okay, let me only do an incremental save at this point. Just as a rule, I kind of usually do incremental saves before, especially before I do any tricky operations with Boolean. So, anyway. I just had to go in there and get dinner going. Making Christopher Lloyd's barbecue. Christopher Lloyd's barbecue. Not really, but anyway, making Cajun spice hot dog tonight. But my beans are in Christopher Lloyd's barbecue containers. So okay, now's for the moment of friggin' truth, right? Okay, can we do these tracks? And again, make sure I save. Now, like I said, for S and G, we can go ahead and and try to do these all at once and see what happens. But again, I don't think it's going to work. I think this thing will have a conniption fit trying to do all these at the same time. Yeah, see, it failed. Like I said, we may not even be able to do a single one of them. So I'm having a hard time with that. Yeah, I have a feeling this is maybe going to be a lost cause on this. See, as it stands, I think it'd be a miracle if this does one of these, let alone 2 iterations through. So I may have to take this to another program and see if I can do it. And it did it. I can't believe it. God, that took a long time. I'm not used to Boolean operations taking that long. That's the longest I think I've ever had one take. You can see what we're after here. See how we have these channels that are done like this. That's what we're after. But usually, if you luck out in Rhino and get it, have it do one that way, you won't be able to do anything else to it. That's the thing that sucks about it. You almost have to turn it to a mesh or something. But we'll try it and see what happens. The computer I'm working on, if you're interested too, is an i3, so at like 3.3 gigahertz with 6 gig of RAM in it. So. And I've got a halfway okay graphics card at a 720. I just got through upgrading it actually because my old one crap out on it. It's a NVIDIA GeForce GT 440, or not 440. That's what I replaced with 720. I think it was. Because again, I had to keep that in perspective because it's got a stock power supply on it, so I can't put too big of a graphics card on it. It doesn't really matter with this kind of stuff, but let's see what happened. Okay, let me lid, diffuser, ring. Hey, it did it. But now we probably won't be able to put a hole in it. Okay. Anyway, I guess there'll be a twist to the left and a twist to the right. I don't want to have to go through all that again. So, that'll be fine. And it's just a prototype. But like I said, when we remove the this part of it, so we can get our guide ring on, because it's that part there, that part right there caps the channel off, so when that's glued into place, the ring won't be removable. So, alright. captured that somehow. But it'll be fine just gluing it on. So at this point, you know, again, we have this inner curve, if you'll recall, which was part of our, you know, part of this ring here. Let me hide the top, you know, the top here. So if I extend this down like that, you know, I think that will be the same circumference as that ring was. You know, that and that, yeah, so it's perfect. So we want to continue that hole, you know, for our wiring on through it. However, before we do that, and again, I wouldn't, given what we just got away with all these Boolean operations, man, we're going to be lucky to be able to drill a hole in this thing. So I think any further modifications I make on this, I'm going to, you know, I'm going to just make a separate attached piece just to be safe. So let's go ahead and firstly, let me save and increment this. I'm going to go ahead and subtract this out of it. Okay, thank God. Okay. So that's got our hollow guide piece made now. So our little slip ring, guide ring, or whatever you want to call it, the diffuser ring, will slide in these channels. And it has two positions of height adjustment that we can have. Okay, so below that, again, we just got this flat ring to attach to. And to this has got to go our electronics bay. And this is going to have so much glue holding this thing together, I'm not comfortable with that. You know, I like there to be mechanical linkages like we had, you know, between the, you know, the top and the lid. You see how this got this mechanical linkage here. You know, so these two, you know, can mechanically lock together. But then this is going to be glued to this. And then this is going to be just flat out glued to whatever we put down here to carry our electronics package. Because again, since this is going to be the bottom layer here, I can't put any features on it, you know, to capture anything, because I've got to print, you know, from here up. So, you know, at that point, you know, we're going to have to look at the next step in this and see where that comes out. So, that's it for this video.